Hello everybody, my name's Clare Farrell and I'm a short course lecturer here at St Martin's. I've been leading the Sustainable Fashion short course for about 10 years. I've also been working commercially in the fashion industry for the last about 15 to 16 years. And I am one of the founding members of Extinction Rebellion, in particular the art department, and also working across actions and many other parts of the movement. It's worth noting that the reason why I've been asked to make this asset is because rebellion and youth strike and global strikes are spreading all around the world in the face of the climate and ecological emergency that we face. There's something shifting and Extinction Rebellion plays a part in that. Young people all over the world play a part in that. It's clear to us that it's a pivotal moment in human history. As Greta says, change is coming whether we like it or not. What we do or don't do now is going to decide the fate, really, of life on Earth and of all of our lives for humanity in the future. So there's a great weight of pressure on us to take stock of what that requires of us as people, and particularly as creative people. There have been decades and decades of inaction and denialism and misinformation, which have led us to this critical point where life is under such grave threat. What I'm going to talk to you about will give you a flavour of some of the sort of science and the rational basis for taking emergency action. I hope it'll inspire people to do more self-education. The assemblies that have begun to happen at St Martin's, I hope will also inspire people to do a lot of collaboration and working together further to try to address the situation. The information that I'm going to present now is quite upsetting. Some of you will find it shocking and sad if you haven't heard the sort of details of this before. There's plenty of information in the press, but I think a lot of people haven't really come to terms with the magnitude of the emergency that we're in. And I guess what I want to say on that front is just that engaging with it, I think, is less painful than trying to ignore it, because the media and the public conversation will continue to get more and more strong, and it's not going to be possible to ignore this ongoing. There's also something about taking action and being in active participation in learning and in acting against this crisis, which can help you very much to feel better in the face of knowing what we know. As creative people, your work is in touch with many, many complex systems. That might mean looking at complex economic systems, complex ecological systems, complex social and political systems. But because of the complexity before us in all of this interconnected world that we live in, it's important to remember that these problems that we face are very challenging, and it's okay that nobody knows a clear answer of a way forward. But what is important is that we bring our creativity to it. We rely on a stable planetary climate in order to be able to run our agricultural systems, our economies, our social systems. And the reliability of our weather patterns has made it possible for us to spread all over the world, to extract and use all the resources to build our growing economies. All around the world, that means that we've been emitting carbon. Carbon emissions come mainly from fossil fuel extraction and burning. That's how we produce the most of our energy. And you may or may not know that carbon-based gases form a kind of blanket around the Earth's atmosphere. Effectively, they sort of trap heat. And we've had just the right amount of those gases in the atmosphere for a very long time, which have kept the Earth's conditions optimum for life. And right now, because we've put so much more there, we're seeing this very great warming effect. That's the simplest way to describe the greenhouse effect, as it used to be known, global warming. Because we've been adding to those very, very rapidly in the last 30 years, that has shifted the planet out of a stable state, or has begun to shift it out of a stable state. Global temperatures are going up quite quickly, and we're noticing that we've changed the weather. So we're seeing more extreme weather events, more droughts, more heat waves. When you have a heat wave, it tends to be longer. We've because the average global temperature is going up. At the moment, we're at around 1 degree C above the pre-industrial average global temperature. It's worth noting that in 1990, scientists told the UN that if we got to 1 degree average global warming, we would face catastrophic consequences. Since that warning, carbon emissions have gone up 60% rather than come down. Now, there's this thing in science called the precautionary principle. The precautionary principle is a philosophical principle which says that basically you don't need to know for certain that a catastrophe is going to happen in order to be able to act to prevent it. It's embedded in lots of thinking in science. It's also embedded in lots of thinking in politics. You can find it all throughout policy within the EU, for example. We have not adhered to this principle in the case of mitigating against the effects of climate change. What it is also a risk assessment. So in that sense, if you think that there is a great public risk and you act because of the precautionary principle, then you don't have the opportunity to go back on that until you can guarantee that the public danger has been removed. Right now, I think it's clear that the public are in grave danger all over the world, some more so than others, because we know this affects different parts of the world in different ways, more quickly some places. What the science also shows us is that the changes that we experience are going to be non-linear, which you can see from this graph. When you look at the blue shape that shows you a smooth projection, that's from the IPCC. That's a prediction of where we're going to see Arctic sea ice melting and disappearing, and the red line shows you the actual measurements. So we know that while science will try to project something that gives us a sort of linear-looking curve, the actual playing out of these effects doesn't happen in such a neat way. Now, the small numbers that we're dealing with can sound really insignificant, 1 degree or 1.5 degrees, but it's important to realise how that 1 degree in average warming can result in very, very much higher average temperatures in parts of the world where it's very hot, for example. The last time the planet was on average 2 degrees hotter, sea levels were 6 to 9 metres higher than they are right now. And the planet looked very different. Ecosystems were very, very different. So on the present course, we expect to see 3 to 4 degrees of warming by the end of the century. That's a business as usual projection, which means that we don't really have any time for adaptation. And it's questionable whether people can adapt to a 4 degrees warmer planet. Scientists don't actually know what that means. Some people have said it's incompatible with our civilization as we know it. To give you a sort of idea of what that means, the south of the UK could have a climate similar to North Africa. And that's coming in 80 years' time, potentially. So the IPCC is the Intergovernmental Panel on Climate Change. It's the world's most respected and rigorous body of researchers and scientists working on climate issues. And that has an interaction with politics because the IPCC suggests policy measures to politicians, and they work on that with economists and people who work in policy. So what you get from an IPCC process is, on the one hand, a very rigorous piece of scientific research, but on the other side, you get recommendations which have been very much affected by people who are considering the well-being, if you like, of the economy. They also work with very, very big data sets. So their investigations and papers can take a very long time to put together, sometimes 3 years. In climate change science, that's quite a long time. So we have the newest information coming from the latest papers, won't be part necessarily of the latest report that comes out of a body of that size. Last year, they gave an emergency recommendation of 1.5 degrees cap. Now, the Paris Climate Agreement says we can warm everything on average 2 degrees C. Everyone agreed to that, although some countries, particularly vulnerable states like the islands, low-lying islands, who stand to lose their whole country due to rising sea levels, have described signing those agreements as the equivalent of signing a suicide pact. So the IPCC now are saying there's a huge difference in the outcome if we keep to 1.5 rather than 2 degrees of average warming. It's important to remember that all of these things haven't resulted in a legally binding agreement. They're just recommendations. As you might remember, Donald Trump has pulled America out of the Paris Agreement. And we expect at 2 degrees, even at 1.5, that many nations can disappear underwater or become uninhabitable due to extreme weather, very high temperatures, drought, inability to grow crops, that kind of thing. One place where we've seen recent hurricanes is the Bahamas. The Minister for Foreign Affairs there in 2017 told people that he thought the next thing on the agenda for the Caribbean would be the wholesale evacuation of the entire Caribbean, not just places like just the Bahamas where they experience a hurricane. They're also questioning in that region not how or where to rebuild infrastructure, but whether to rebuild it at all, on the assumption that they'll become climate refugees very soon. Now, locked into our Earth's systems and climate systems are many feedback mechanisms. Positive reinforcing feedback mechanisms are not positive because they're good, firstly. The simplest example to show you is the albedo effect. Now, we lose the albedo effect when we lose the Arctic ice. The albedo effect is the effect that is caused by having white surface on either end of the planet, on the polar regions, and the sun's energy that hits those spaces bounces off. The majority of that energy goes straight back out into space. Now, obviously, as the ice melts, you get a dark surface, which is either dark water, or you lose the snow and you get dark rock. Both those types of surfaces then absorb more heat rather than reflecting it. So you can see as the ice shrinks, it gets hotter more quickly, and then it's going to get faster and faster until there's nothing left. So there are many more feedback loops in the system. Another one, for example, is the dieback of the Amazon, which people expect to happen somewhere between 2 and 3 degrees C, that the Amazon forest, which is often known as the lungs of the Earth, will either die back or burn down, or a bit of both. And you may know that politically that's under threat anyway, because people are slashing it and burning it in order to turn it into sort of commercialized agricultural space, and in order to use the materials that are there. Now that's a big problem for us, because if we lose the Amazon, we don't just lose a very large carbon sink that sucks those gases out of the atmosphere, and we need very much for them to do that, but we also turn it into a carbon producer. So the smoke and the pollution that is coming from wildfires, and particularly from burning down rainforests, which isn't just the Amazon, it's also happening in other parts of the world, that's sort of double problem, if you like. In 2018, there was a paper that came out which was actually quite unprecedented in some ways. It got called the Hothouse Earth paper. If you were living in London at the time, you might remember the headlines that were on all the newspapers that said the Earth could shift into a hothouse state, which we wouldn't be able to pull it back from. And this was really a scientific paper that was focused on how there are these tipping points and feedback mechanisms in the system which scientists don't have a huge amount of data to be able to make accurate projections with, so they don't often like to publish whole papers about them, but we know that they're there. What this paper said was that the mechanisms are there that could create a runaway warming event, and that beyond 2 degrees of warming, human control over carbon emissions could stop being the main driver of climate change, and it could start to self-perpetuate in a way which we can't halt. So scientists, Johan Rockström, who's a very well-regarded climate scientist, said, right now scientists are becoming extremely worried. Another paper that came in 2018 was this one, What Lies Beneath. This was a kind of think piece. Foreword was written by this scientist called Schellnhuber. He's an interesting scientist, I think. If you're doing your own research, look him up. He advises the Pope and Angela Merkel. He's a very credible member of that community. And he says climate change is now reaching the end game. The issue is the very survival of our civilization. He asks the question in the opening part of this paper, the foreword, of whether or not we've used the correct philosophical and intellectual approach to look at this moment, and recognises that science isn't usually tasked with performing a risk assessment, and states that we've greatly underestimated the existential risk of climate change. And he's recently come up with a new way of looking at climate risk, which takes inspiration from the insurance industry when they multiply the likelihood of an event by the level of damage that they anticipate, and also looking at the way that air traffic controllers work. They analyse the time that you have left to make a response to an accident which is incoming. So for me, he's really a scientist who's worth looking at in terms of his openness to think about the way that we think about this stuff. So we've changed the weather, and there is more extreme weather that's already with us in many parts of the world. More intense storms, more hurricanes, more monsoon rainfall in the wrong regions where people are not used to it. That means more flooding. We're also seeing more wildfires. As I'm filming this, there have been wildfires this week in California. And there'll be many more problems in hot parts of the world where it gets too hot for people to cope without having access to any air conditioning, which of course uses a lot of energy and will give greater carbon emissions if we have to have air conditioning everywhere. This means heat stress and heat-related illness will become more prevalent in more parts of the world. We know that that relates to kidney strain, for example. We know that in heat waves we lose elderly people more quickly. And we also know that heat waves will not only become more frequent, but they'll be longer in length than we're used to. This summer just gone, some parts of India reached 50 degrees C plus. And this puts a massive strain not only on human health, but of course then on health services. Now the centre of continents warms quicker than the outsides of them. The centre of continents is where you will find many of the regions that we describe as the breadbaskets of the world. These are the regions where we grow lots and lots of crops at very large scale. And growing grain crops at scale and storing them as dry food is the backbone of civilizations. We anticipate a drop in those crop yields because of temperature increase, because grain crops don't like to be grown in average higher temperatures if they go up sort of more than 1.5 or 2 degrees. And particularly then the central continents where you find these spaces, those crops may experience a much higher increase. They could experience an average 4-degree increase in temperature, for example. This is a problem with a growing global population that needs to find ways to produce more food to feed everybody. It also means with more extreme weather and more unpredictable weather that these crops are going to be susceptible to these issues as well. You may have one year, you have flooding in one region, you may have a drought in another region. And food security experts call the likelihood of this problem popping up at several places at the same time multi-breadbasket failure. Now, the risk of this happening and creating a global food crisis is going up all the time that we heat the planet. This isn't just going to affect food, of course. If any of you work in fashion or other disciplines that require materials that are grown, then this will also create an agricultural issue for many, many industries, not just food. Last year, some EU countries reported a 50% drop in their crop yields, and a couple even declared that a state of national emergency as a result. This means you get a food price spike, so that affects the poorest people very quickly. It can lead to famine, it can lead to displacement of people who can't live where they live anymore. And when you have mass displacement of people, you often see wars breaking out. We've seen the beginning of a refugee crisis here in Europe, and I think many people expect that to get much, much worse. This can also relate to water shortage. This has been shown recently in some major cities, so you can look up the news about Chennai in India and Cape Town in South Africa if you want to see what happens when a city completely runs out of water. Another effect is sea level rise that we're going to see from a warming world. This comes from the thermal expansion. Obviously, water takes up more mass, takes up more space when it gets hotter, but also when we lose ice that's held in glaciers above water, that's going into the ocean. So this is kind of where sea level rise starts to happen. And the Arctic is warming much, much faster than other parts of the world. So the ice is shrinking much more quickly than I think scientists used to think was going to happen. So we anticipate flooding of coastal cities around the world. In 2018, the World Bank projected that by mid-century, there could be 140 million people displaced due to sea level rise. In the UK, some people think that could be up to 10% of the population who are displaced. This level of social upheaval is unprecedented, certainly in the UK, in generations, and I think very hard for people socially to cope with if that many people lose their homes all at the same time. And earlier this year in 2019, the council in Wales decided to decommission a village called Fairburn from 2025 because they know that it won't survive the sea level rise that's coming and it's low-lying. So people are already beginning to prepare to move entire towns and villages, actually. So another paper that came in 2018, which is worth mentioning, and it is very hard to read just because it's so sad, is this paper, Deep Adaptation, by an academic called Jem Bendell. He broke the mold somewhat in academia in telling the sort of narrative around climate change and breakdown and how that demands us to engage in a very rapid project of deep adaptation to the changes that we've already committed to. And in that paper, he outlines that he thinks social collapse is inevitable and could come soon, that immense catastrophe is very likely, and that human extinction is a possibility. He's one of the people who thinks that it could lead to a social catastrophe. Another UK academic, Kevin Anderson, who's a climate scientist, he's a very plain-talking scientist, I recommend you look him up, he's excellent communicator, has described that we would rather question physics than our economic model, and that scientists have actually been relatively rather self-censoring in recent decades, and importantly, that policy writers are relying on negative emissions technologies that don't exist. So carbon capture and storage technology, which will draw that carbon down out of the atmosphere and put it away, was anticipated to be developed at a certain point in the future by policymakers. So when people agreed to the terms of the Paris Agreement, they agreed to it on the assumption that some technology would help later down the line that didn't actually exist at the time. This is something that I think people deserve to know because I don't think people really realise that people have been writing policy based on things that aren't actually workable yet. It's my understanding that now this technology does exist, but it is very hard to imagine how it can be optimised and scaled in time to take part in the work that needs to be done in terms of drawdown. Now, the UK government have a very, very bad track record of taking action on climate. They've consistently written policies that make things worse. Two things which are very notable are committing to the expansion of Heathrow Airport, so the increase of aviation emissions. This may be partly because they don't count aviation emissions as part of our carbon budget. So whilst we say that we've lowered our emissions in this country, that's because we don't count shipping or flying. Also putting fracking, forcing fracking onto communities that didn't want it. So we know that hard to reach fossil fuels like gas that's in shale should be left in the ground. Aside from that, they've done lots of other things like give less incentive to buy green cars, scrapped solar subsidies and refused tidal power projects, sold off the Green Investment Bank. So there are many, many things that the British government have done to actively make this situation worse and not better. And we know that emissions are still going up, especially methane. Methane is a more powerful greenhouse gas than carbon dioxide, and globally we're seeing methane emissions go up very, very much more quickly than ever before. So on climate change, that's one problem covered, broadly speaking, but there's another thing in the room, which is the loss of biodiversity. A lot of people have been describing the time that we live in as the 6th mass extinction event. If you look into the geological record, you can find 5 major extinctions that have happened in the planet before. This new time that we find ourselves in, scientists started to use the term biological annihilation to describe it. And there's a question for a lot of people now about whether we really are in an extinction event like the ones that have come before, or whether you could call it the first mass extermination event, because we don't have any information that shows that a sentient species has committed to the previous extinction events. There's a very famous saying, the dinosaurs didn't see the asteroid coming, what's our excuse? So we know ocean acidification is set to double by the end of the century. This is a problem because it undermines the base of the food chain and it affects coral reefs, much of life that relies on a particular pH for the ocean. And carbon is constantly sucked down into the water, which acidifies it. We've known about this since the late 1800s, actually, scientifically. We've got air, soil and water pollution the world over. The World Health Organization say that it's somewhere around 7 million people die every year prematurely because of air pollution. In London, for example, there's almost 10,000 deaths a year because people are breathing such toxic air. And the situation has been the same for some time now, even though the government have been found guilty in court, in the High Court and in the Supreme Court. We've got soil erosion problems, so the loss of the quality of topsoil. Topsoil's very much alive, and through very, very intensive agriculture, we've damaged that, and the British government think that we may be 30 to 40 years away from a fundamental loss of fertility, meaning that you can't grow good crops because your soil is dead. Now, there are many factors leading to the loss of wildlife. One of them is deforestation and loss of habitat. We know that there are massive problems with intensive agriculture as we do it all over the world. There are huge carbon emissions from meat production. The UN think that about 14.5% of global emissions may come from livestock. And forests are naturally reservoirs of biodiversity as well as carbon sinks. By contrast, large-scale monoculture agriculture often creates a one-way process towards desertification of the land. We're also overusing pesticides, herbicides. We're seeing the massive, massive loss of pollinators and insect life, which we rely on to pollinate the crops to get our food to grow. A 2019 report by the IPBES, which is a little like the IPCC, but looking at biodiversity loss, estimated that 1 million species are now at risk of extinction. And one of the causes of this destruction is overconsumption, and particularly overconsumption of resources by the richest people in the world. That means us lot. There's a direct link between your financial status, your income, and your impact on the planet. And Professor Kevin Anderson makes a great provocation to this, which is that by going to university, you increase your chance of making more money. And by having more money in the future, you'll probably buy a bigger car, a bigger house, you'll have more opportunity to travel, you'll eat more expensive food, and all of those things you can expect to make your carbon footprint bigger. And there's another paradox which I think is relevant to look at in the context of thinking around sustainability. The first place people go to when they think about this stuff is often efficiency. Now, there's an economist called Jevons, so this is called the Jevons paradox often, and he noticed that when we make an efficiency saving through technology, at that time with coal, we didn't use less coal because we needed less, we actually used it more because we could use more and get more from it. We saw this average sort of increase in consumption, although we technologically made an efficiency saving. And that paradox is still present with us today. When we make energy savings, we often find that energy consumption or material consumption continues to increase. For me, as a person who's been teaching sustainability for over 10 years now, I am very interested in what this shows us, because for me, it's quite clear that we don't sometimes know how to ask the right question in order to be able to find a good solution. Now, through the work with Extinction Rebellion, we found that this information can bring people to a place of grief. And there's a new word, I think it's new, Solastalgia, which describes a homesickness that you can have for your planet, or an emotional response of feeling sad because of environmental destruction or devastation. And I believe that without us turning something around in the shape of a miracle, that there will be much more of this feeling around. And what we've asked ourselves, and what I think a lot of other campaigners in other spaces have asked themselves recently, is how does this affect the way that you want to live? How does it affect the choices that you make about your life? And what kind of emotional and embodied response are you going to make to the moment that we're living in, knowing what we know? Now, for us, that's meant a virtue orientation for life, an opening up of our hearts, really, and a looking to other people to take action with in order to create this paradigm shift that we want to see. And for me, it means living in purpose. So really, I'm not doing very much of the work that I used to do before, but I am feeling greatly empowered by a sense of doing what I think is the best work that I can possibly do right now in my own capacity. And as I said before, I think just staring at bad news can make you feel terrible, of course. But knowing that there are ways to take action and there's much creative work needed to be done in order to get us through the times that we're heading into, it gives us something actually very exciting and very dynamic space to go into, where it's possible to imagine that we can actually change a lot. And we've been inspired at Extinction Rebellion by lots of people who've taken direct action, civil disobedience, the campaigns that have really changed the face of our societies, got black people the vote, got women the vote, things like looking at how Gandhi fought for Indian independence. And those things have been very inspiring to me to see that actually social change has happened before and could happen again in the future if enough people get behind it and willing to take some action which may result in the change happening. As students who are going to enter the economy after graduation, I asked myself what I could do to help you in light of the fact that you're often being trained to serve the creative economy. Mark Carney, who is the ex-governor of the Bank of England, has said recently that we face economic collapse with ecological collapse, and that if we ignore the ecological crisis, then businesses will fail. I would hope that in the future we're all going to live through the sort of retooling somewhat of the global economy so that it functions in a way which doesn't just destroy the conditions for life. This brought us to ask the questions, what are arts institutions for and what is culture for? How should education respond and how should we support one another whilst we go through this change? And so now I'm going to introduce you to a couple of people who we've worked with creatively on building the rebellion, and hopefully they'll show you a little bit about the ways that they've collaborated towards making something that hopefully creates change. And then there'll be a second part to this film which you can watch, which will show you lots and lots of practitioners who've worked with like radical sustainability and green agendas for a long time, people who've put the planet as a sort of major stakeholder in their work, or the natural world as a major stakeholder in their work, and also people as a major stakeholder, rather than just looking at only making profit or only producing things to make money.